Forest landscapes play a crucial role in regulating the global climate cycle. To sustainably manage our forest ecosystems, natural capital and environmental assets, and maximize their value, it's essential to understand the location, causes, and rate of forest landscape change. Satellite images, aerial photos, and other remotely sensed data are continually capturing the Earth's surface at different locations and time points. By following changes in land cover over time, we can identify the location, scale, magnitude, and types of these changes. Through advanced analytics, change detection solutions can now improve the accuracy of forest and land cover classifications, identify trends, and determine the drivers of change. All of this information helps us understand the impacts of past decisions, current conditions, and to plan for the future. For over 25 years, Tessera has been at the forefront of innovation. Recently, our team has been designing and developing advanced solutions focused on forest and landscape change detection. Our approach leverages temporal, remotely sensed satellite imagery and machine learning to identify and analyze transformations across various landscapes. We recognize that change is an intrinsic and continuous process, unfolding daily and at multiple scales across the globe. The fundamental challenge and key to successful detection lies in precisely defining the appropriate spatial, temporal, and spectral scales at which to identify and interpret these changes. This nuanced approach allows us to understand the types, geographic extent, and rates of change occurring across the landscape, providing actionable data for adaptive management. Land cover change detection services, while valuable, often present a significant challenge due to the coarseness of their reporting scale. That is, the spatial and temporal resolution at which the changes are analyzed and reported. Many of these service offerings commonly analyze and report on changes at the raster cell level, with resolutions typically ranging from 10 to 30 meters or even coarser. These raster approaches lead to fuzzy and grainy imagery that can often lead to a mismatch between the raster-based data outputs versus actual on-the-ground features. Tessera's approach utilizes fully scalable vector-based polygons. Tessera begins by first segmenting the landscape within the area of interest into discrete land cover polygons that have similar structural characteristics. These land cover polygons form the analysis units and baseline over which to begin change detection. Based on historic temporal data, we model the normal phenology, or cyclical seasonal change, over each analysis unit. Subsequently, we analyze each analysis unit for abnormal change and provide a statistical probability of change as compared to the baseline. The advantage of Tessera's vector-based approach is that it's fully scalable and provides detailed data and statistics at the polygon level, and it can be easily aggregated to larger operational units while maintaining all of the data and statistical precision. When appropriate historical background data is available, we can even model and predict the change agent, including drought, fire, flood, or insect infestation. Our scalable change detection solutions provide timely, actionable data regarding the types and location of forest landscape events. Equipped with this knowledge, forest, natural resource, and carbon managers can sustainably manage and maximize the value from their forests, natural capital, and environmental assets. How can we help enable your team, project, or opportunity? Let's connect. How can we help?